And welcome back. Previous videos, we've been working on objects or bodies that are subjected to forces moving on a plane that is along the horizontal axis. In this problem, in this scenario, we will be working on objects that are moving along the plane. However, this time the plane is not parallel to the horizontal axis, so it means it's not flat anymore, but instead it is inclined at an angle measured from the horizontal axis. So it's like this. So in the sense that there isn't anything holding the block should slide down to the lower side of the ramp or the plane. However, because there is the existence of what we call friction, okay, friction is preventing it from sliding down. Okay, so friction is preventing it from sliding down. As you have done in your lab activities, you have noticed that when you raise or increase the angle of inclination, what happens is your block will definitely slide down, and it will slide down as it reaches that certain angle. And how would you know that certain angle can be determined using applying some of the calculation techniques, and at the same time the law of motion, or Newton's law of motion, that we've been applying for the past couple of videos. So in this video, or in this equation or problem, we are going to figure out the coefficient of friction. But since the problem stated that the block remains at rest, so if, in order for it to remain at rest, of course, it's called static, and that static coefficient of friction. So to be exact, we're trying to figure out the coefficient of static friction, and at the same time, what is the maximum angle? How would you know the maximum angle before this block will start to move depending on your mass? Okay, depending on the mass. Now, first thing that we should do is your free body diagram. So let us draw our free body diagram. So as always, free body diagram. So you're gonna get used to drawing the free body diagram with this kind of problems once you see the inclination is there. First thing is that we must have the x and y coordinate. Okay, so just like what we've been doing in the past, we will draw an imaginary x and y coordinates. However, with this drawing, since our plane is not along the horizontal axis, but it is at angle theta from the horizontal axis, so therefore our imaginary x and y coordinates should be rotated as well, and the x-axis should be parallel to our horizontal plane, or parallel to the plane or to the ramp, like this. And then of course our y-axis should always be perpendicular to our parallel line to the plane, which is our x-axis. So let us draw a perpendicular line, which is our y-axis. That is your dot. Okay, so dot is right there. Now, if I'm going to draw my dot right here, and there's always force due to gravity. Gravity is always pulling it downward this direction. So let us draw our free body, our force of gravity, or the weight of the object, which is Fg. Okay, so Fg. Now, again, there should be a normal force because there is a contact between the object and the plane that is at an incline. And we all know that normal force is always perpendicular. So if I am going to draw, let's say this one, using my pencil to draw this imaginary line. So let's say this is parallel, like this. I'll be drawing the y-axis. Okay, so this is my y-axis and this is my x-axis for those of you. Okay, so let me just draw it a little bit darker. It's my pencil, so it's drawn a little bit lighter. So let us draw our normal force, which is at this point. That is normal force. Okay, so normal force is always perpendicular to the surface, so that's why it's perpendicular to the surface. And then of course gravity, so we all know that it's going to move to the left, so along or towards the lower side of the plane or the inclined plane or the ramp. So force of gravity should be going the opposite direction. Okay, so it should be opposite direction. Maybe right here. Okay, I can always adjust my drawing later. So I'm looking at this one. Okay, so maybe like this. Okay. Might be not correct. Let's see. So this is our coefficient of static friction. Coefficient of static friction. So that's my free body diagram. So free body diagram is finished. Now those are the different forces that we have on this block. There's no applied force. There's no F that's being pushed or pulled on the block. So now let's continue with our solution. So solution, it's the same process. Let us draw our force of gravity. Right here, let me just call it Fg, of course. So the Fg so let's put it here, Fg, which is mass times g. Okay, mass of the object multiplied by the acceleration due to gravity or the gravitational field strength. Next is our normal force, which is somewhere here. So Fn. And then we have our force of friction, which is somewhere here. So here's our normal force of friction, static friction. Now just for the sake of easier to see, so what I'm going to do is that I'm going to extend this and call this one as our x-axis and this is our y-axis. X and y-axis. Now if you notice, our force of gravity is moving downward, not along the y-axis, but instead it is at an angle measured away from the y-axis. Okay? So every time you see an inclination like this angle is the same as the angle of your force of gravity, but this time it is measured along the y-axis. So this is our theta. Okay, so this is our theta, and that is your measurement. And then since you have your x and y, you can actually measure this. Let's use the blue one to designate our x component, and then the red one as our y component. So this means I have my Fg along the y-axis, and this is my force of gravity along the x-axis, Fgx. Okay. Now in terms of our functions or components, let's say Fgx or Fgy and then Fgx. We have learned this in a previous video. We have seen this in a previous video that your y is usually sine function if it is measured along the x-axis. But since the angle is measured along the y-axis, then instead of using sine function, we will be using cosine, as demonstrated in one of those questions that we deal with in the previous video. Now, our y will be cosine, and our x is going to be our sine theta. Since we are measuring the angle along the y-axis instead of along the horizontal axis, we have to switch which trigonometric function are we going to use in order to figure out the value of the components of the force, that is applied at an angle not along the axis. So now that we have seen that there is y and x component along for our force of gravity, but not along our friction or normal force. So this time, let us draw the third free body diagram. So if this is our third free body diagram, so if I have my Fg right here, which is mass times g, then I have my force of friction right here. So force of friction, and that is equivalent to the coefficient of kinetic friction and the normal force. And the normal force is going to be somewhere along here. That is perpendicular to our, so that's our normal force. Now for our vertical components, force of gravity, we notice that we have our Fg, x, and then we have our blue, which is right here now. So let's call this one, sorry, Fgx, while the red one is Fgy, because that's along the y-axis. Okay, so along the y-axis, along the x-axis. So now, let me just extend this so we know that this is your x-axis. X-axis and y-axis. So if we start by working on our summation of forces, now we can start applying our concept of law of motion by adding our forces along the x-axis, along the y-axis is equivalent to mass times the acceleration along the y-axis. So let's take a look at this. Your x-axis is this, or your y-axis is this line right here. And if you notice, there's no motion going this direction. So we can say that in terms of acceleration, acceleration along y-axis is 0. Okay. Even though there's pending motion to slide along the x-axis, since according to our problem, the block is at rest, so the acceleration is also 0. So it's a motionless system. By plugging in different information that we have here from our diagram, positive going up, so that's your normal force, minus your force of gravity y is equivalent to mass times the acceleration, that is 0. So normal force minus Fgy, so that will be Fg cosine theta equals 0. Now we can say that your normal force is simply equivalent to Fg cosine theta. But Fg is also mass times g, or mg right here. So we can change this Fn and express our answer in terms of mass multiplied by g cosine theta. So that will be our normal force. Now, how about studying the different forces acting along the x-axis and the acceleration of the block along the x-axis? So now if we figure out the summation of forces along the x-axis is equivalent to mass multiplied by the acceleration along the x-axis. Again, forces going to the right is positive, so going to the right is your force of kinetic friction or static friction minus Fgx, and there's no other forces acting along the x-axis anymore, so that's mass multiplied by 0 since there's no acceleration. So you can say that Ffs minus Fg multiplied by sine theta equivalent to 0. So that is equivalent to 0. So if we have our force of friction So we can say that force of friction is equal to, so if we move it to the other side of the equation, that will change it to positive, so that is Fg sine theta. Oh yes. However, we know that FFS is, or the coefficient of static friction, is simply, or friction, static friction force is equivalent to the coefficient of static friction multiplied by the normal force. And our force of gravity is simply equivalent to the mass multiplied by g times sine theta. Fn is simply mg over cosine theta, times cosine theta. So let us replace the value of the normal force, and that is mg multiplied by cosine theta, and that is equivalent to mg sine theta. Now we all know that we can cancel mg and g, or if we want to divide both sides of the equation with mg, cosine theta. So you will have mg sine theta over mg cosine theta. So mg will cancel, mass times g. So now we have our coefficient of friction is equivalent to sine theta over cosine theta. But if you are going to figure out something, if you analyze this, what is sine theta over cosine theta? Sine theta over cosine theta is basically tangent. So we can also say that the coefficient of friction is simply equivalent to the tangent of the angle. So it's either, in your multiple choice questions, sometimes they will ask you to express your answers or to pick the correct answer, and sometimes it's multiple choice, multiple correct answers, so you can select either sine theta over cosine theta or simply use the tangent function. So this is for letter A. So for letter B, what is the maximum angle that we can use? So what is the maximum angle that you can use? So you can use from number 1. Okay, so we can use from number 1, what is that maximum angle that we can use using this number 1 right here. Okay, for letter A, I'm sorry, using our solution from letter A. Okay, so let me just draw a line right here. So this is for letter A, and then for letter B. So for letter B, in order to prevent it from moving, or to have the equal amount of force acting along the x-axis, so it will not slide, it will not move, so the same amount of force, we can figure out the angle, which is mu s so by using this, we can say mu s equals tangent theta. But what is tangent theta? Or what is theta? How would you get theta? This is simply the arcsine of, or arctangent of, what is the coefficient of friction. Okay, so coefficient of friction. So as mentioned here in this solution, tangent theta, or the angle, is arctangent theta of mu s. Now, what is the maximum angle? Okay, what maximum angle? So as I mentioned earlier, it needs to be balanced. So force is balanced. In order to be balanced, then you have the same amount or same distance and the same height. So that means that in order to get a balanced height, where this is our height and this is our, well, this is the opposite side and this is the adjacent side. So that's the height of the inclination, and this is the run, as we call it, run, and this is your height. So that's the slope. And if run and your height are equal, then we will form an angle that is equivalent to 45 degrees. So therefore, in order to experience the maximum angle, it should be 45, where the force coefficient or the force of friction is equivalent to the force of gravity along the x-axis. So that's 45 degrees.